How does a mechanical clock work? So here we've got a vintage Seth Thomas. This is actually probably, I'm guessing 1940s, maybe 1950s, definitely after electrification had become very common. This unit was never designed with a counterweight that would need to be wound by manual human power. This one had a factory integrated counterweight winder. So normally in a previous application you would have many feet, often the height of a church steeple, that the counterweight would drop through, called a chase, and then at the top of that there would be a winding mechanism with a one direction tooth system so that somebody could crank it up to the top, all the way to the top, skip. Once it's at the top, that tooth locks in, and then the counterweight begins its descent down. But basically, how these work in general is the main drive shaft is going to have a counterweight acting on it at all times, and that counterweight is constantly going to be putting downward rotational force on a shaft in the mechanism. This shaft will be by way of either a complicated gear set, depending on what other complications the clock has, or in this case a very simple one, putting rotational force in one direction on that shaft, and that shaft has a metering device connected to it. So what we see here is called an escapement, and basically it is allowing a 1 second's worth, so basically 1/60th of 1/60th in terms of the mechanics, 1 second's worth of release for each one of these little ticks. And each one of these ticks corresponds to the motion of the pendulum here. And basically, the center of mass of the pendulum kind of determines how fast that tick back and forth happens. This knob here allows a micro adjustment to lower or raise that center of mass to really dial in how long a second is. We know how long a second is, but this allows us to fine tune it, and then over the course of an adjustment period where basically you take a 12-hour cycle and say, okay, we gained a fractional amount of time. That means I need to make my second longer, or we lost an amount of time. I need to make my second faster. So basically this thing is just constantly putting pressure on this rotating shaft, and this metering device, the combination of the escapement and the pendulum, is controlling how fast that counterweight is able to drop and basically put enough force on the system to rotate the hands, which in this case we've got a little distribution gear that in the past would have gone up to the clock. This system has been retrofitted with new electronic components, but if you see that hole right there in the middle, that would have, this shaft here would have gone to that hole, and then this distribution gear would have basically translated that motion out to each of the 4 clock faces, and we would be keeping time.